Welcome to a lesson with Dr. Powell. Let's take a look at exponents a little bit, positive and negative exponents, and what they mean and how to work with them. All right, let's suppose I have 2 and I raise it to the third power. What does this mean? This means that I'm multiplying um, 2 3 times. To what? To 1. That's where we start. When we're multiplying, it's kind of like the starting multiplying number. We can kind of think of 1 as being kind of like the empty lot of 2's, like there being no 2's I've multiplied so far. So 2 to the 0. 0 means how many 2's I have with the 1, and I only have 0. I don't have any 2's. Here there's 1 2. Here there's another 2. Here there's another 2, and I'm multiplying these together. Notice what exponents do. They change multiplication into the addition of some numbers. Okay, see this? See if we add 0 plus 1 plus 1 plus 1, and we get 3, and that's that guy right there. So similarly, if we have like 2 cubed times 2 to the 4th, this is the same as 2 to the 7th. How many factors of 2 you have? We have 3 factors of 2, then we have 4 more factors of 2, total 7 factors of 2. So multiplication now turns into a statement about addition. 3 plus 4 is equal to 7. All right, what about negative numbers? That's kind of like removing factors of 2. So for instance, if I have like 2 to the negative 3 times 2 to the 5, what would this mean? This means I remove 3 factors from 5 factors to have a total of 2 factors. Notice how it just adds. So how many times do we remove a factor? Or in some sense, it's how many times do you divide by 2? So we could say 2 to the negative 3 is the same thing as you start at 1 and you divide by 2. Then to that result, you divide by 2. Then to that result, you divide by 2 again. Well, but let's think about division a little bit more simply. In algebra, we like to think about everything in terms of multiplication instead of division. So what does it mean to divide by 2? It means to multiply by half. Okay, so we're thinking about multiplying by half 3 times. Okay, starting at 1 here. So 1 times a half times a half times a half. Which we could also, so we're taking a half of a half, which we get a fourth, and then we take a half of a fourth, which is an eighth, right? Which we could also think about as just simply saying 1 over 2 cubed, where we've multiplied, where we thought of this as just multiplying the denominators together, 2 times 2 times 2, with the 1 on top. Okay, so what we can do is we can think about, so if we have an expression like 3 to the negative 5 times 2 cubed, we could rewrite this simply as 2 cubed over 3 to the 5th. Because we're thinking that we're taking, because this, remember, is the same thing as 1 over 3 to the 5th times 2 cubed. We can move the 2 cubed to the outside right here. And so we're taking 1 over 3 to the 5th of this. Why? Because we can imagine, we know that this is the same thing as dividing by 3 5 times, or just multiplying by a third 5 times. So 1/3 to the 5th times 2 cubed. Okay, so this is a nice property of negative and positive exponents, and we know that exponents add together. Something else that we know about exponents is grouping. You see right here, I've actually done a grouping right here. Notice I didn't write 1 over 3 to the 5th. Instead, I wrote 1/3 to the 5th power. That's like saying 1/3 times a third times a third times a third times a third, because I'm multiplying it by 5 times. Now notice that we can actually, that when we actually do this out, it's like you're multiplying the denominator, so of course it's 3 to the 5th on the bottom. So this would be another way of writing it down. Exponents distribute over division. and multiplication. So if I have like 2 times 3 and I square this, this is the same thing as saying, see, this 2 can actually distribute to both parts across the multiplication. Interesting. Exponents represent repeated multiplication, and so they distribute over it. That's a key idea to always remember. If something represents a repetition of something else, it distributes over it. So this could be 2 squared times 2 cubed, or 2 squared, sorry, 3 squared. Okay, I'm mixing up my words. So 2 squared times 3 squared, because we think of this as 2 times 3 times 2 times 3. Okay, and then we can, multiplication is commutative. What does that mean? And associative. Associative means that you can remove the parentheses if you want, and it still means the same thing. That's what associative means. And then commutative means you can rearrange the order if you just have multiplication. So these 2's can be grouped together, and these 3's can be grouped together. And so you have 2 factors of 2 and 2 factors of 3, just as indicated. This happens so you can distribute over an operation which is commutative like this, and where what we're doing distributes over, or what we're doing represents repeated of what we're talking about. So exponents are repeated multiplication, so they can go over it. They're also repeated division, or fractions or whatever, so you can distribute over fractions, because fractions are like multiplication anyway. Like, 1/2 times a third, there's a multiplication there. So if we have this raised to the 5th power, look what it can do. The 5 goes to the 1/2, and there, and so the 5 can come down here because it goes to both parts, the 5, so the 1 and the 2. So 1 to the 5th is just 1. That's why I just write 1 there. 2 to the 5th, and then times 3 to the 5th, which is simply 3 to the 5th, 2 to the 5th. So so that it can distribute across division or fractions kind of really is the same thing as distributing over multiplication here. So kind of nice. So exponents distribute over what? Multiplication and division. But maybe to end the lesson today, let's talk about what exponents don't distribute over. And this is important. So what if we have 2 plus 3 and we want to square it? Some people are tempted to say, hey, it distributes over the addition. So they might say 2 squared and 3 squared and try to add them, but don't do that. That's not good. So we're not going to do that one on this. And so what can we do with this? What we can do is we can, well, simply just perform the addition if we wanted to, but we're going to be moving to variables where we can't always just combine things, because what if we had something like a plus b, things we didn't know, right? We need to know what, like, we're not going to be able to combine them because we don't know how to combine them, because we don't know what these numbers are. So we actually leave them alone. So really, algebra is the way that we do operations with things, where we just assume and remember that we can't always combine things. Notice in some of these videos, I've left things in factored form and didn't combine them. And that's because in algebra, we have lots of variables and you can't always combine stuff. So we gotta figure out how to work with things separately. I mean, it's pretty obvious. If you take 2 squared and 3 squared and you add them together, we get 9 and 4, that's 13. But 13 is a lot different than, this is 5 squared, 25, right? Ooh, yeah, so that really doesn't work. So if you look at, so as you are learning algebra and different rules of arithmetic and things, it's always helpful to look at examples to see if really things work or don't, because the two will not distribute over addition. Part of that is that exponents do not represent repeated addition directly, at least. They represent repeated multiplication. So exponents, repeated multiplication. But what does distribute over addition? We should know this. Multiplication. Why? Because multiplication is repeated addition. So 5 times 2 plus 5 times 3 would work. So you can distribute this way, but this does not distribute that way. Okay, so keep that in mind as we're working with when we're working with exponents. So in summary, what have we talked about in this video? We've talked about we've talked about exponents being positive, being negative, how they represent addition, how you add exponents together. Now we've also talked about how exponents distribute. They can distribute over what? They distribute over multiplication. They also can distribute over division, but they do not distribute over addition or subtraction even. And we'll stop here in this video, and we'll have more to come in the next one. Thanks for watching.